Thank you very much for inviting me to do my presentation. I'm hoping it's of interest to some people, but if I may, I will start up with the screens. Okay, well the good news is you've managed to miss the first screen, which was very bright and very technicolor. I apologise for the graphics and the artwork. I've just used one of the standard presentation slides, which saved me having to find a lot of artwork for myself to make it look pretty. But back onto topic, so I'm Michael Shaw. I've currently work for Pay Global inside MYOB. It's an enterprise level payroll product. It's written about 25 years ago and developed ever since. My background is about 15 years as a software development side, and then 10 years after that focused more on the delivery of software, either as a DevOps engineer or as a physical product in some instances. The final part that I need to cover before I start is that although I work for MYOB, and I'll be talking about my experiences working on a product for MYOB, these are my own personal thoughts and my experiences. I work on one product inside MYOB. We have a lot of other products, and the experiences and the technology used on a lot of the other products is very, very different. And they are solving different problems in a very different environment. So, the starting point is legacy software. So we're talking about deploying legacy software. So for me, we're talking about a desktop application. It's two-tier. So it's a monolithic application which talks directly to the database. And it was written assuming a whole series of things about the OS that they could use for doing a lot of the application control and security. So it's all mixed in with talking about Windows networking shares and lots of things like that, which these days you would not touch. Likewise, there's not service-oriented architecture, there are no microservices, and there are no containers. This is not cloud software by any stretch of the imagination these days. Okay, so what do I mean by cloud hosted is the next part. So particularly for me, it's virtual infrastructure. The infrastructure is available on demand, and getting the physical provisioning of things is somebody else's problem. I just need to say I want a virtual machine, and it becomes available, and making sure there's the hardware to run it and CPU resources and the memory. That's, for me, that's AWS's problem, not mine. And the last part, before I start, is why Puppet? There's plenty of other tools out there. So when I joined MYOB, we faced the situation of what products were we going to use for doing the automation. And several people on the team had experience with different products, but we went with Puppet. The two, probably the biggest things, was the declarative model, the ability of deciding these are the resources that we care about, and these are the properties of the resources that we care about, and we want the system to look like this. And the great thing about that is it does not matter about the starting point. Puppet will either set up the system to look like that, or you get an error. And that solves one of the big problems with deployments, is that when you deploy something and it doesn't work, how do you roll back? Well, you just deploy the previous Puppet pattern, and it knows how to get there. And the second part that we really, really liked was the hierarchical configuration. So that allows us to have one set of configuration, and we can deploy it anywhere. And that's not just for deploying to each of your different servers, but it's also deploying that same configuration, same set of configuration for your test environments, your developers' environments, and respinning all of your different profiles. So they could all be on the same machine, or in your production environment, you could have them scaled out across multiple servers. And that last part, the role profile match, we had a look at that model, and we felt that that was a really good point as well for being able to define all of the networking rules between EC2 instances and the IAM permissions. So if you define your profile and says, this profile talks to these other profiles, and this profile needs these AWS permissions, we can define it at the profile level, And then when we're spinning out roles and onto machines, we can combine all of that to actually generate the AWS resources that we actually need. So that was the engineering designing that we did before we jumped into this. And we now do Puppet managed AWS Cloud. So how do we do that? What does that look like? Technology. So there's a few AWS resources that we need to care about. On the networking side, VPCs, subnets, router tables, internet gateway, and NAT gateways. And on the hosting side, on the infrastructure side, for the providing the resources, auto-scaling groups, launch configurations, so security groups and their rules, RDS instances, and the IAM roles for policies for allowing the manipulation of AWS as well. So, first thing you do, we don't want to write the software ourselves. What's out there that we can use? So the first thing we tried was to use the Puppet Labs AWS module. We tried it, and it kind of worked, but we kept bumping into edge problems that we had to work around. And we came away thinking, not only can we do better, but we probably need to do better to make it work for us. So using the AWS and the Puppet Labs AWS module was a non-runner. We were going to need to do something different. So we then looked at what do we actually need to do to actually model AWS resources inside Puppet to get us the functionality that we needed. And we figured that the best way of manipulating the AWS environment was to use their command line tool, their Python AWS CLI. That seemed to be the most up-to-date of their tooling. And we could use it as a provider inside Puppet to actually do the manipulations that we need. And it allowed us to then focus on modeling each of the AWS resources to allow them to behave in the way that a Puppet resource needs to behave, so that we could then use it in the way that we want to use it with Puppet. So here's an example of a Puppet manifest. And on this one here, we define a VPC. We care about the region, the CIDR range, we want DNS to work, and we want to put a tag on it. And it's as simple as that. And then when we apply it, this is the result. 8 seconds later, thereabouts, we end up with a VPC created. It's worth noting that AWS do a few extra things in the background, side effects. There's also a default route table, and there's a default security group. And we do a couple of extra things with those by giving those default names inside the code. But that's just making things behave in a more Puppet-like way for us and actually allow us to manipulate those resources as well. And that's an example of the VPC that gets created. It's tempting in the AWS world to manage things using the AWS ID, but that doesn't work with Puppet because you cannot predict the ID before you start. So we have to, in our implementation, we've used the name tag. And so all of our resources, we give them a tag with a name on it, and then we use that inside Puppet to be our unique identifier. So how did we make that work? What is involved in making your own custom resource? So there's 2 parts to a custom resource. There's the type declaration, the properties, the dependencies, and the validation rules around each of your type. And then there's the provider part, the implementation, which Puppet then uses to actually do the work for you in the background. So we're going to have a look using our security group components as being a straightforward one to demonstrate how that works. So here's an example of a manifest file. Notice how we've split out the security group from the security group roles. That was quite an important thing for us to do early on. When we started with having everything built into the same resource, and then we have two security groups, quite often you would want to create rules to say that security group A can talk to security group B, and security group B can talk to security group A. But the problem is to create those rules, the security groups have to exist, and you can't create part of one, then part of the other one, and then go back and finish off creating other parts in the first resource. With Puppet, you have to create everything as a one pass. So we split them into two separate resources, allows us to create all of the security groups, and then for us to manage the rules separately. And I believe CloudFormation uses the same approach. So for us to define a rule, we say the network family, the port, and for us there we've defined the SG is short for security group, but it could be a CIDR, and we could specify an IP address range in there if we wish, but we've made our own language for defining how the network rules are all defined for being implemented. So what does that look like? So it's a real simple type. We're starting off here with declaring the security group rules at the top. We're saying the dependencies. So before we're requiring the security group to exist before we're adding in all of the network rules for that security group. And likewise, if we're deleting the security group rules, ensure is set to absent, then we're making sure that we are deleting our rules before we're trying to delete the resource, before we're trying to delete the security group, and that ensures that all of the Puppet dependencies work properly for us. And then all we then need to do is just define the in and the out properties for each of the rules. And we've put in a little bit of validation just to ensure to determine whether or not the rules are in sync or whether or not there is a change here that needs to be applied. And the basically is quite straightforward. If everything is in your this is what we want list, so your should list, and we're looking at the is list, or these are the rules that are already there. If those two lists are the same, then we don't need to do anything. If there's differences, then it's out of sync, and Puppet then does its magic for us in the background. So that's the type side. So then we have how do we implement a type? So what does the provider look like? Well, providers don't actually need to do very much. They are a collection of getters and setters for the properties. We need a method in there for creating a resource. We need one to delete or destroy the resource. We need one to find the resource and work out whether or not the resource already exists and and what its properties are. And we also need to do a flush on there to say, right, so we've got the new properties for this resource. Now update the real resource with these properties. And that's it. It's really straightforward. So here's an example of us creating the security groups. I'm doing a check to make sure that the security group already exists. There's a resource for it. And then we're just saying these are the network rules that need to be applied for the in and for the out. And then a bit lower down, they see a different thing there that's doing the destroy. And likewise, we're doing on the flush, we're saying these are the rules that need to be applied. And the function which everything seems to come back to is the apply network rules. And really, really straightforward. If we've got a set of network rules that we're planning or that we want the resource to have, and we know the list of network rules that the resource already has, all we need to do is say, well, the ones that we want, any of them that don't exist or don't already exist on the resource, they're the rules that we need to add. And likewise, the rules that are already on the resource, but are not on our list of planned resource rules that we want on the network, they're the rules that we need to delete. And so you end up with two lists, the list of things that we need to add, and then we do some Ruby code to add each of those network rules one at a time. And then we also have the list of delete rules, and then we just work through and we delete those one at a time. And it's as straightforward as that. So what we found was once we'd worked out the mechanics of how to write our own custom resource, it was quick. Typically, we could model a simple AWS resource in about a day. It was easy to test, and we found that once we'd done our implementation, done our testing on it, we found them to be a reliable building block and very easy for us to keep reusing. And we found over time that we've had very, very few problems or defects that we've missed in our initial stuff, and we've moved on really easily. So the next part is deploying legacy software and taking the role and profile model, where most people who use Puppet will be familiar with using that on a server and bringing it into the cloud. And the cloud's brilliant because Puppet is all about how do we configure something and set things up, and the cloud allows us to do that often, frequently, and much, much more often, and provides us some tools for doing so. And we chose to use the launch configuration, which defines how to build a new server, for actually getting you the virtual server that you need. The auto-scaling group, which controls when do we want a server, how long do we want it for, and in which subnet or VPC do we want to place it. And AWS Code Deploy, which allows the triggering of deployments to happen on the server to update the software. And we came up with the basic premise. If you create a Code Deploy package that contained everything about the Puppet environment, all the Puppet modules, the hire data, all set up ready to use, and we had that set up for the Puppet agent to run in a serverless model, then we could use that for setting up the server. We wouldn't need anything else. We could just have everything pushed onto the machine, and it can use its facts to identify which profiles needed to be applied for this particular server role. And that would solve that problem for us easily. We figured that if we use the auto-scaling group to set a role tag at the EC2 level, then we can use a Puppet fact to feed that into the actual deployment inside the Code Deploy package when that's running, so that the machine knew which was its role and would select the appropriate profiles to install. And that if we did that at scale across all of our different server roles, we could still throw the same deployment package to each of our servers, and the tags on the auto-scaling group would allow the right things to be installed for that particular role. So it gave us one thing to test, and we could throw it everywhere, and it would set up all of the machines. And if it was that easy, everybody would be doing it. There wouldn't be a talk worth doing. It would be common knowledge. But there were a few challenges. One of them, idempotent infrastructure. Puppet wants to make changes to things, to resources that already exist. That's its model. AWS launch configurations. You create one, you can't change it. So having to deal with how we're going to model that for Puppet was one of the challenges on there. And we took quite a simple approach with that. We thought we'd fake it. So we created our Puppet launch configuration model resource to pretend that you could change it. Then when you did make a few changes, well, we threw away the old one. We created a new one with the new properties, and the auto-scaling group says, oh, there's a new launch configuration resource that I need to connect up. And surprisingly, it works. Now, for us, we're dealing with Windows and joining Active Directory, because for our permissions, the machines need to be part of the Active Directory. And when a Windows server spins up and then joins the domain, it then has to reboot. AWS with when you're spinning up a new machine, you are able to specify a user data script, which allows you to programmatically set a few things when the machine spins up, such as installing a domain or installing the Code Deploy agent and the Puppet agent. And the moment the Code Deploy agent is installed, it downloads the package, which then runs Puppet and starts setting up the machine. And about 30 seconds later, the Active Directory domain join completes and server reboots halfway through deploying. That does not work. So, what just happened there? Okay, so jumped ahead when I shouldn't have done. So we ended up having to solve that problem by creating our startup script using Windows Task Scheduler. So we would create the code deploy agent and the to be installed on the server reboot. So after the Active Directory is joined, server reboots on spin up, then it installs the code deploy agent, and that then allows the package to get downloaded and for Puppet to then starts running. So we then delay that, and then everything then works. So as a broad summary, things that we found easy were creating the custom resources, modeling the AWS side. We had to do a few creative things, but on the whole, that was quite a straightforward thing to do. Puppet and getting new EC2 servers to behave inside the AWS world, that was more of a challenge. And I've explained one or two of them so far. There is a whole heap of them, and we've been working through those for much of my time here, finding new rough edges. And over a few beers, I'm quite happy to discuss more of them with people. But I'd say the final part, the thing which we found the most valuable, is the layer above the individual AWS resources. And that's the logic that works out which resources that we need. So if you know the profile that you're putting on each of your servers, or the profiles that you're running on them, you can then work out all of your security group rules that you need for each of your different roles to talk to each other, the IAM permissions for it, and calculating and generating all of that information from your base facts, so that when you're then deploying the cloud, that is all generated for you, rather than you having to try and work at the individual AWS resource levels and work out all of those details. So it takes away the burden of having to manage the equivalent, or the Puppet equivalent of your CloudFormation script. Puppet just works that out for you. And I think that, for me, has been the biggest gain. And Puppet has proven itself to be a lot easier to work with than trying to manage CloudFormation. Okay, so that covers the sections that I wanted to introduce to you guys. If anybody's brave enough with any questions, I'm more than happy to hang around and answer them.
We have one question in the chat. We want to clone the configurations in the server to a new one so that we could spin off same configurations to other newly built servers during the Puppet run. What could be the baby steps that we should look at?
So for me, the approach that I've taken is I have looked at how do I build up a replacement machine first, by incrementally. So you have your existing server, and the terminology we use is we call that a pet server, one that we lovingly nurture, we interact with on a daily basis, we look after it, and we manage its every individual needs. And what we do is we then start building up what we call a cattle server by incrementally adding in additional profiles to building it up, so we then match the functionality that we have on the pet server, and then at that point we switch them over. So we then have a brand new machine that we can spin up on demand using Puppets to deploy everything, that we know the configurations are good and it's an exact match, and we just swap it over that way. And it then also forces you to fully understand everything that's gone into that machine. So often with the pet servers, engineers and DevOps engineers over the years have been adding to them, oh, we've got that problem, okay, I'll just add this on. They didn't document it, they didn't do proper tracking, and then it gets to a situation where people then start being nervous going to a machine because they don't, well, we don't really know that bit, it works, we don't want to touch it. And by working in a Puppet way with the profiles to build up and adding in more profiles to the role, it becomes very obvious what is on the machine, and it becomes very safe to work within a single profile and say, oh, in this profile, I understand this, I'm working inside that area, I can make changes safely, and we can test that on its own standalone machine really easily. And then when we are comfortable that everything is good and that we have now built up a machine that's a functional replacement, we just swap the two over. And then we remove the pets and we remove another pet from the system, and we have a new cattle server or set of cattle servers.
Alrighty, I think that's it for the Q&A, but thank you very much for that talk, Michael. It's really interesting to see people operating Puppet, particularly in AWS, and the way you guys are doing it. You know, you're using essentially what people would deem to be a modern platform, but trying to run a legacy platform. And it's definitely like one of the biggest challenges I see out there is a lot of people, they want to modernize, but the fact is that they're still got to maintain the legacy side of things.
I think on that point, it's a really good observation I've got is we have a lot of our newer platforms are managed by the guys over in Melbourne, where they're doing things in a very, very cloud way, using all of the latest technology, Kubernetes, Slam, serverless stuff, you name it. But every time they come to Auckland, they make a beeline for my desk because we're the guys who've got the interesting problem. Everything they're doing is all very straightforward. We're the ones that have actually got to do some real engineering to actually figure out how to solve the problems.